In this lesson, I will show you how to add two or more vectors. Remember that a vector has both a magnitude and a direction. We did that in class recently. And we also started to look at how you might add some of these vectors together. But we only did easy ones, really. So in this lesson, I'll be adding 4 vectors instead of just 2. And we'll do one that's a little bit tougher and show you how to do that. Before we begin, make sure that you have these vector notes, which you should have gotten in class. Also, you need a ruler and a protractor to help you with this lesson. So, the first thing we need to do is talk about what vectors we're going to add together. And I'm just going to pick some to do, and we're going to try to draw them to scale. So, the first one I want you to draw is a vector that is 3 meters per second straight east. 3 meters per second straight east. So I'm going to draw that right here. And I decided to use centimeters to make it to scale. So you can see that my vector now is 3 centimeters long, and I'll draw it 3 meters per second. And the angle, of course, is straight east, so it looks like that. The next one I want you to draw is 2 meters per second at 20 degrees north of east. 2 meters per second at 20 degrees north of east. So here's what I'm going to do. I'm going to start off by drawing the east line. You just drew east up here, that's straight east. So I'm going to draw a dashed line that is straight east. Should be parallel to the first one. Then I'm going to go 20 degrees north of that. So on my protractor, I just count up, let's see, this is 10 and 20 degrees north of the east line. Now I need to draw the vector in, and I said it was 2 meters per second. So I'll do 2 meters per second at 20 degrees north of east, and it will look like this. And I'll label it 2 meters per second, and then this, like I said, is 20 degrees north of east. And I'll even put that on here, 20 degrees north of east. The third vector I want you to draw is one that is 1.5 meters per second at 45 degrees south of east. 1.5 meters per second at 45 degrees south of east. And this is a good spot for me to remind you, if you're watching a lesson on YouTube, a flipped lesson, you can't watch it like you would a normal video on YouTube. You're not just watching. You need to actually do something with it. So that's why we have these notes. And you should stop periodically and see if you understand it. So this would be a good point for you to stop the video, see if you can draw a vector that is 1.5 meters per second at 45 degrees south of east. And then start the video again to see if you're right. This is a great way to learn, to try it first and then see how it goes. So here's what the vector looks like. Again, I'm going to draw the east line. And I said I'm going to go 45 degrees south of the east line. So with my protractor, I find that that value is right here. And I said it's 1.5 meters per second. So I'm going to go 1.5 centimeters just to keep it to scale. And it's going to look like this. 1.5 meters per second at 45 degrees. And I can see it south of east, but I'm going to write it on here anyway, just because this is new for everybody. Then the fourth vector, it should be another easy one to draw, 1 meter per second straight south. There we go, 1 meter per second due south. And I really don't have to write the south here or the east here because the vector shows you the direction, so there's no reason to put it in there. Now, the next thing that we need to do is take these vectors and add them up. That's the whole point. But you can't just say 3 plus 2 plus 1.5 plus 1 because these are all different directions. if the vehicle was going 3 meters per second straight east, but then had a wind or something, a force pushing on it in this direction, you can't say the total is 5 meters per second. They're not in the same direction. So what we'll have to do is get all 4 of these to have sort of a common language that they can use. And the way that we're going to do that is by breaking these into components. So the first component, the first components for the 3 meters per second is, those are pretty easy. The x component is 3. It's 3 meters per second. The y component is 0. There's no vertical part to this at all. It's all horizontal. It's all east. Now on this one, it's not that easy because you can almost see it in the picture. There's a x component and a y component. You could break this one vector into a vector that's this way and this way. Those would be equivalent to each other. This one vector would be equivalent to a vector that was this direction and then this direction. And using trig, we can find out what those two are. So you may remember from trigonometry how to find these different sides. If I'm looking for this side of the triangle, I have the hypotenuse, that's 2. I have this angle, and this side is adjacent to that. So if I have adjacent and hypotenuse, that sounds to me like it's going to be SOHCAHTOA, so cosine. And this is how I'm going to do it. I'm going to say, let's see, the cosine of 20 degrees is adjacent. That's kind of like an x component right here. The adjacent, I'll call it x, over the hypotenuse. So SOHCAHTOA, adjacent over hypotenuse. So that's over 2. You do some quick math on that, you can realize that x is going to be equal to 2 times the cosine of 20 degrees. So I'm going to write that over here just to remind myself how I got it. 2 cosine of 20. And when you punch that into your calculator, you should get 1.88. Make sure you're in degree mode if you don't get 1.88. Now, we also need the sine. That's this side over here. That's the y component. So you do the same type of math. This time it'll be sine of 20 equals opposite. That'll be y over hypotenuse. Again, that's 2. And do some quick math on it like we did over here. And you get 2 sine of 20. Gives me the y component. And plugging that in your calculator, you get 0.68. This would be a good spot to stop the video and see if you can get the x and y component of this vector. Here's how you find the components of that vector. Now, I can kind of see it here. Here's my x component, and here's my y component. It's like I'm taking that vector and breaking into a triangle. And this vector plus this vector, the two components, would be equivalent to this 1. If I go this way and then this way, that's the same thing as going like this. So now this time, if I'm looking for this side, let's see, it looks like I'm going to use cosine again. This time it'll be cosine of 45 equals adjacent, which I'll call x because it's the x component, over the hypotenuse, 1.5. So it'll be 1.5 times the cosine of 45 degrees. And for those that know enough about trig and remember it, you'll remember that it's 1.5 sine of 45 would give you the other side, and those two will be the same for a 45, 45, 90 triangle. So then we can go over here, punch it in your calculator, and you get 1.06 for the x component and 1.06 for the y component. And if you do it that way, you're really close to correct, but you're not exactly correct. And here's why. This vector is to the east, so that's positive. But this component, vector, is to the south. So I've got to make that negative. This has to be a negative y component because it's going down, it's going south. And so what I'm saying is this one vector of 1.5 meters per second is equivalent to doing 1.6 this way, and I'm sorry, 1.06 this way, and 1.06 down. Lastly, we need to do this one, and hopefully you can again stop the video and figure these out, the x component and the y component for this guy. The x component for this time is going to be 0, because there's no east or west part of that. It's straight south, and so it's going to be 1 here, but again, it's going south, we have to make it a -1. It looks like that. Now, the reason we did all that, it seems like it's a lot of work, and it is a lot of work. The reason for all of that is because we could not just add these numbers straight up, because they're all different directions. But now we have everything into either x or y directions. That means this as an x, that's straight east, this is straight east, this is straight east, and there's nothing here at all. If these are all straight east, now I can add them up. Now they're almost in the same language, if you will. They're for sure in the same direction. When you add those up with your calculator, you should get 5.94. Make sure you verify that with your own calculator. In the y direction, something similar, but now I have two different directions. The first one had no y component. Don't have to worry about it. The second one had a y component, a y component of 0.68. The third one was negative 1.06. So those are two different directions. This one's up, this one's down, or north and then south. So I have to kind of subtract them. We just did it as negatives and positive. Positive for north, negative for south. If you combine all of those, you get a total of negative 1.38. So what we found here is that adding these four vectors, even though they're in very different directions, can be done by first putting them in the same direction, either x's and y or y's. Then you combine them. This is the total of all the x components, the total of all the y components. The next thing we need to do is draw a triangle using those components. So the total of all the x's would be 5.94. So I can take my ruler, and again I'll try to do this to scale. So it's 5.94, and that should be straight east because it's positive, it's got to point this direction. Then we have to draw the y components. Now for the y components, as you add them up here and draw them in, you have to always add your vectors what we call tip to tail. Tip to tail means on the tip of this one, I've got to put the tail of the next one. So the y components are negative 1.38. The negative, as you know by now in physics, is the direction. So that tells me that it's south. So I can go south 1.38. I cannot draw it here. That would be tail to tail. I'm going to do tip to tail. So the tail of the y component vector goes right here. We draw it straight south, 1.38. And it looks something like that. You don't have to label these every time, but for now I'm going to label this 1.38, and it's meters per second since that's what we were doing before. All these vectors are a velocity, are velocity vectors. Here again, I mean, there's what I'm talking about with tip to tail. I've got the tip of this one on the tail of this one. And you'll find out pretty soon, it doesn't matter which order you go in. You could draw this one first and then the next one, but you still have to do tip to tail. Now that we've done that, we're going to find what says here, the resultant magnitude. Well, the resultant, as you should know from your notes already, is the result of adding these two vectors together. So this is the total of the x's, this is the total of the y's. To combine them, you draw the hypotenuse in. There you go. So this is your resultant vector. Looks like that. This whole thing right here. Now we want to find the magnitude. The magnitude is the number value with it. So I've got 5.94 on this side, 1.38 here. This is a right triangle. So I can use Pythagorean theorem. Remember, you can only use Pythagorean theorem on right triangle. So if you Pythag this, then you, well, you know Pythagorean theorem, right? A squared plus b squared equals c squared. So I've got 5.94 squared plus 1.38 squared gives me, I'll just put c because that's what you do in math. That's my resultant. You solve for that and you get a value of 6.1 meters per second. Again, make sure you can do that on your own calculator. Don't just trust and follow me. If you can't do it on the test or the quiz, you're going to be in big trouble. So this is my resultant magnitude. And I'm going to go back up to here and label that 6.1 meters per second. That's the combination of these two vectors. Now the thing we have to do next is find the resultant direction. The direction is one of these angles in the triangle. Now you already know this one. And we could find the other two using trig. Only one of these gives you the proper direction though. The angle that you're looking for the proper direction is this one. And the reason for that is because the arrow, the resultant vector, this guy right here, points away from this side. So I want to know, where is the resultant vector pointing? It's pointing for sure south of east, but I don't know that angle. So you can use some trig here. And you know three sides, so you could use sine, cosine, or tangent. For no particular reason, I'm going to use tangent. Any one of them works. If I do the tangent of theta, where this is theta, let's see, tangent SOHCAHTOA, TOA, that's opposite over adjacent. So opposite would be 1.38, that's opposite the angle, divided by adjacent to the angle, that's 5.94. We have to take the inverse tangent of that ratio, and we get our angle. So plug those into your calculator, and you should find that theta turns out to be 13 degrees. That's this angle right up here. Now every vector has a resultant and, every vector has a magnitude and a direction. Here is the magnitude. Here is the angle direction. Our final answer has to also include north, south, east, west, and so on. So the final answer, that is the resultant of adding all four of these together, gives you 6.1 meters per second at an angle of 13 degrees. And now we got to figure what's that what direction is that? Well, that's 13 degrees. This is the east line, so we're going south of the east line by 13 degrees. If you do that, you get 13 degrees south of east. So if we go back to the original problem, we were adding these four velocity vectors together. I'm thinking of a flag that has four different velocity vectors to it in some way. Some different fans are blowing on it. What does a flag actually look like? What's the total wind speed of all those fans blowing together? This is how you would do it. Add them up by finding the components. Redraw your triangle. Find the resultant. That's just the magnitude. Then find the direction. Lastly, figure out what direction it is on a compass rose. 6.1 meters per second at 13 degrees south of east. That's the resultant. The one vector that is the combination of those four. And that's how you do it. Sometimes you might be using sine or cosine, sine and cosine differently up here, but it's all trig, Pythagorean theorem, and your sine, cosine, tangent functions. That's how you do it. It is tough, but hopefully you'll get the hang of it pretty soon. That's the end of the lesson. Make sure you bring this with you to class. Also, check down below this YouTube video to make sure that there aren't any additional instructions that you need to fill out.